Hello and welcome. In this video I'll be showing you how to find the equation of a tangent from the equation of a curve. So right now I've got 2x squared plus 3x plus 2, and of course we know that our x squared graphs look like this, positive x squared, and then negative x squared graphs would look like this. So ours is positive x squared, so ours would look like this, and or something like that. And we know that we have our point here 216 on this curve where a tangent would cross, intersects, and we're trying to find the equation of this tangent from the equation of the curve. So the first thing to do is look at it. So obviously a tangent is a line, therefore the gradient here would be constant, and we know that for a line the equation would look like this. So y is equal to mx plus c. The m would be the gradient number, so a 5x would be gradient of 5. It could be something else, I don't know. Yeah, plus c. And c is obviously the y-intercept, so it would look something like this, the tangent equation, because the tangent is a straight line. Now, the first step is to find the gradient. How we're going to find the gradient? We know that on this curve, the gradient is constantly changing. Right now, it's in this end, it's negative, it's going down. In this end, it's positive, it's going up. And there's actually a way to find the gradient at a certain point, an x coordinate point. And the way to do that is actually to differentiate. So if we differentiate this equation up here, so I'll differentiate it now. So then dy over dx. So differentiating the curve. So I just bring this down here, bring down to differentiate it. Now equal, well, 2 times 2 is 4, so 4x then minus 1 power by 1, so it'll be to the power of 1, and then plus just 3 because minus 1 to the power of 1 minus that, and you get power of 0, which will just be 3. And now we just get rid of this one here, this 2. So now we have this equation here, 4x plus 3, and we can actually sub into this. We can sub in the x value, which is 2. So if I just sub in the x, now 4 times the x value, which over here is 2. So we can just do 4 times 2 plus 3, and then we'd get 11. That would equal 11. Now what does this 11 actually mean? So I write it here. So 11 is the gradient of the curve 2x squared plus 3x plus 2 when x is equal to 2. And we know that, so therefore at this point the equation of the curve at this point, so the gradient at this point is going to be 11. And in this equation for the tangent, we can say because the gradient of the curve is 11 at this point, so will the gradient of the tangent, as you can see in the blue line. Now if we sub that in now, so if I just write this in black again, actually I'll do it in blue. So if I bring this down here, so I can actually sub in for m, because m is equal to 11. Like that, the 11 that we found here for the curve is equal to that. So we can say that y is equal to 11x plus c. Now we've got our y, we've got our x, but we won't be trying to, because we've got our y and x values, we're trying to find our c, because the c is the y-intercept. It's the one value we're trying to find. Now if we find the c, we'll be finished with our question. And to find it, well, we use our y and x values. So we've got our y, which is 16, we've got our x, which is 2, and we know because it says here that the tangent intersects the curve at 216, so we know that the tangent goes through the x point 2, y point 16. So we can sub in for x and y. I'll do this in different color, so green. If I bring this down, I'll be okay. So y, which is 16, is equal to x, so 11 times x, which is 2, and then we've got plus c. Now if we do this multiplication, we'll get 22, and then we'll get plus c, and that will be equal to 16. Now if we actually go and minus this, I'll do it, I'll put a little arrow here as well actually. Now if we go and we go and do a bit more calculations. We can do 22, so if you just minus the 22 from here, so then 16 minus 22 is equal to C. Now we know, therefore, that C is equal to minus 4, I believe, or is it minus 6? So 16, 20, 17, 19, 20, 21, 22. Yeah, so minus 6, sorry, minus 6. And we can complete the equation now, so I'll do this in black. So if I write the rest of the equation, we know that our C value is minus 6. So I can write y is equal to 11x minus 6. And that'll be the equation of our tangent. So in this next question here, we've got a few different things. Well, actually only one different thing. We've only got our x coordinate, which is minus 2. And that's the problem, because we have to have our y coordinate to find, our final answer. So to do that, we're just going to sub in. So obviously here you see y is equal to 3x squared plus 5x plus 2 for the curve. It's equal to y. So if we sub in for x into this whole thing, we can actually find y. So if I just write this down here, except for the fact I'll just sub in for wherever there's an x, I'll put a minus 2. So 3, and then minus 2 squared, and add 5 times x, which is minus 2, and then you'd add a 2 at the end. So it's just the exact same as the equation up here, just adding in minus 2's wherever there's an x. So of course, because of BIDMAS, because this is minus 2 and we're squaring it, we'll have to do the squaring first. So minus 2 squared, minus 2 times minus 2 is 4, positive 4, which is because a negative times a negative is a positive, and then 4 times 3 is equal to 12. And then of course we're adding this to 5 times minus 2, which is, well, minus 10. So then I'll write this here, minus 10. And then of course we've got plus minus 10 plus 2. Minus 10 plus 2 is, well, minus 8. I'll actually rub this out. So minus 10 plus 2 is minus 8. And now if we have minus 8, so this is plus minus is basically just minus. So if I just do this, make a little long minus sign, then 12 minus 8, and that should be 4. And that all that means is that our gradient, so 12 minus 8, which is 4, and this just means, as I've said many times before, that 4 in this case is it's not the gradient, but it's actually the y value when x is equal to negative 2. And now we can find everything else. So we can start off by differentiating the function like we did for everything else. And I'll do this in a different color. So if I just substitute in and differentiate, so 3 times 2 is 6, dy over dx, and this would be equal to, well, 6x plus 5. And now we can just sub in. So of course we've got our x values, so 6 times minus 2 plus 5, that'll be minus 12 plus 5, so that will just equal minus 7. So I'll write that in a different color, I'll write that in green. So, and then of course minus 7 is what we've got before the gradient now. So I write this in a text box again. So I'll write minus 7 is the gradient now when x is equal to minus 2. And actually we know why, we know that's going to be 4. So we can just write when the coordinates are minus 2, 4, because we've already got y, we found y here. And now we can finally go into the last step, and that is subbing in to find our c value. So if I get my minus 7, so y is equal to minus 7x plus c for x and y. What x being minus 2, y being 4. So if I just sub it in now, so 4, and that would be equal to, of course, minus 2. So if I just write this in, so minus 7 times minus 2, and then of course plus c at the end there. And now if I just multiply everything out, so minus 7 times minus 2 would be equal to 14, because negative times a negative is positive, so 14, but I'll move the 14 to the other side, and that'll be negative 14, so I'll just write it as 4 minus 14. And this, I'm just doing this quickly, so there's less space available, so I don't want to write it out individually. And of course that would be equal to c, and therefore you know that c would be equal to minus 10. I'll just put a little box around that. And now of course, because you've got our c, we can just, that was the only unknown left here, because we already had the rest of our equation, minus 7x plus c, so that's the only unknown left. We can just literally write it out now. So I'll put a line here, and now I'll just write out my final equation. I'll write it out again in, I don't know, let's write it out in red, shall we? So of course it's the same as before, so just y, same as right here, so y is equal to minus 7x, just like over here, plus, not c, but it's actually minus 10, sorry, minus which c, which is minus 10. So, and if you're wondering, it's plus c because if we actually sub in for c, then if we have plus minus 10, does that make sense? If we just add plus minus 10, then that would just, the plus would just go away, and then it would just be minus 10. So the plus does still apply, that's why I thought I'd let you know why the plus was there. But yeah, thank you for watching to this point, and there's going to be one more question after this, a do-it-yourself question, and hopefully that'll be informative, and hopefully it's been informative so far. But yeah, thank you for watching. So this is the last question. It's a do-it-yourself question, and you guys will have to do this question on your own, as the name implies, and you'll be doing this and pausing the video here and unpausing it when you've figured out the answer, and I'll be going through the answer after you've paused it. So pause the video now, have a go. Answer. Of course, you can see here you've got your answer of y is equal to 15x minus 4 as the equation of your tangent. And you can see the entire process here. First, of course, you differentiate it to get 2x plus 9. Then you of course get your gradient, as I have said here. 15 is the gradient at this point, and therefore is the gradient on the tangent as well. And then of course you sub in, because in this question you have your y and your x. No need to get your y in this question, so you can just sub in for both of them and get your value for c, which in this case is minus 4, and then you can just add that in, so 15x plus c, which is minus 4. So your final answer of y is equal to 15x minus 4. Now, hope that was informative, and this was the last question. Hope you got that question right. If you didn't, just go back and check your answer. But yeah, thank you for watching. Hope this video in general was quite informative, and thank you so much for watching. Have a good day, and please subscribe actually.